Okay, now we're going to talk about an example of a language that it doesn't even satisfy recursive enumerability. So it's called the diagonal language, denoted L sub D, and it's a set of all encodings of Turing machines M, such that M is a Turing machine that does not accept its own encoding as input. So if you feed M into itself, M does not accept. So either M rejects or M gets trapped in a loop forever. So you can think of it intuitively as a set of all machines that reject themselves. So we're going to prove L sub D is not RE. How? We're going to do it by contradiction. So we're going to assume that LD is RE. If you're a recursively enumerable language, that means you've got some Turing machine T such that the language of T is LD. So exists a Turing machine T such that the language of T is equal to LD. Okay? So far so good. T is itself a Turing machine, which means T's got some encoding, right? So we're going to let C be the encoding of T. C is some binary string. L sub D is a language, which is a set of binary strings. Of course, the natural question to ask is C a member of LD or not? And herein lies the contradiction. So let's do both cases. We're going to suppose C is a member of L of D. Okay. C is a member of L of D. So the encoding of T is a member of L of D. What does that mean? Well, if you're in the diagonal language, that means you do not accept yourself. So T, fed an encoding of T as input, does not accept. But if C is in the diagonal language, that means T must accept C. And C is equal to the encoding of T. So these two facts contradict each other. Okay, must have been the case that C wasn't in L of D. So let's assume C is not in L of D. Okay, if C is not in L of D, because the language of T is L of D, that means T cannot accept C. Therefore, T cannot accept C. Okay? If C is not in L of D, that means this condition here is falsified. So it's also true to say it's false that T fed encoding of T as input does not accept. So if it's false to say this machine, if it's false to say T does not accept the encoding of T, therefore T accepts the encoding of T. So therefore T accepts the encoding of T as input. But the encoding of T is equal to C, so T of C accepts. These two facts contradict each other. Well, I mean, C's got to be either in LOD or not in LOD, and in either case we get a contradiction. That means we made a bogus assumption somewhere, and this was the bogus assumption, assuming that the diagonal language was recursively enumerable. So there really do exist some languages that are just beyond the power of Turing machines, even if you only want like one side of the acceptance. Even if you permit the machine to not halt or do something silly when the string's not in the language, you still can't do it for some languages, such as L of D.